It's episode 6, breaking down the basics. This is the long form content. We're talking about P&ID editing and upkeep. This one we'll talk just in general. Next week's we'll talk about MOCs and how you edit there. So a couple things here we're just going to point out in the first section. Really get into detail of what details need to be on the P&ID. So an important thing to point out, because I see this a lot, is our P&IDs are not isometric drawings. And what I mean by that is, a lot of times I'll see a P&ID that's got a ton of elbows, that's got a ton of switchbacks and force, and that's because that's how the piping is in the field, but it really doesn't impact the arrangement. So an important point there is, if it doesn't impact the arrangement, you don't have to show every angle in the line. When we're doing our PSV calculations and we're doing the things where those restrictions come into play, that is going to be done on our isometric drawings, not on our P&IDs. Okay, so the details that you do need, though, it's important to have equipment tags and information on there. Would always have the design information in some sort of box, whether that be on the bottom or on the side of the page, whatever that looks like, whatever that template looks like for your company. We'll try to have the equipment information there for our pumps, for our vessels, those max ranges. Also, it would be good to have operating ranges. Materials construction would be super important for your MOCs and your maintenance. Anytime somebody's inputting something new, obviously they're going to look at the pipe spec, but it'd be great if the pipe spec, then that has to correspond to what the P&ID is saying. All right, so those are some details just from a overarching things that aren't connected standpoint. Really what's important as well is your interlocks. That's where we start getting into connected points, your control valves. Those things need to accurately show what type of valve, what type of device it is. Is it a ball valve? Is it a gate valve? Is it actuated by air? Is it a diaphragm valve? Those things are important. A lot of times we don't pay a lot of attention to those. We just pull the nearest kind of valve documentation that we have. Let's make sure when we document it, we're documenting what kind of valve it is. That's important then due to the operation. Additionally, what are those valves contacted to? You need to show the connection between the instrumentations, the elements. If it's DCS, make sure you do the indication that corresponds to DCS for your plant. If it's SIS, same thing. If it's Z functionality, if you add a Z to those devices, make sure you're adding that there. That's going to be very important for when we're reviewing it in our PHA. If somebody's making a change, they need to be able to look at the P&ID and understand this information without having to go through all the other documentation. Now, obviously, if we're designing something, we will look at the associated documentation, but we should be able to get a clear picture from the P&ID, how everything's operating, how your trips operate, how your controls operate. All right, so a big thing there that also gets missed is, let's say that trip is then activating a device on another P&ID. Make sure within the tag information we have that other P&ID tag information. So next we'll show you a couple of examples of interlocks and details when you're editing these P&IDs to make sure that we're getting everything that we need to understand the process. Here's an example of what we're talking about with the XVs and the tags. A lot of times when you have these XV points, you want to put basically what is it tripping, what's the trip number. Sometimes we call that the SIF action, or whatever your company designates as that's the action. You want to list that. And then this is the example that I was talking about in the larger conversation, is this trip device is on a separate P&ID. So we also in the tag here have sketched the P&ID number where we can go and find SIS 021. So that's going to be important for your inspection staff. That could be important for your operations when they're doing their training. It's definitely going to be vital for the PHA team. So next, what we want to talk about is our field walk. That's going to be important to editing these P&IDs. And we want a draftsman, or we want an operations personnel, somebody, maybe both, maybe an engineer, somebody who's going to understand how these drawings need to be laid out. So once again, I'll go back to a previous point I made. It's not an isometric drawing, it's a P&ID. So one thing we want to point out and do a lot in our field walk is check our valve sizes, and our nozzle arrangements. Okay, so nozzle arrangements, where they are on top of the vessel, may not be quite as important on our P&ID, but we definitely want to capture all the nozzles that are there and what their sizes are. A lot of times this can be difficult to actually put all of that on a P&ID. A good technique to do is you can draw a straight line across the top of the vessel on the P&ID and extend that top, and that gives you enough room for all the nozzles. The reason I say arrangement may not be the most important is when you're drawing your P&ID, you want to not cross a whole bunch of lines if that's possible. So you can set up the nozzle arrangement on the drawing to where you don't have that spaghetti effect and all those lines cross mingle with one another. Just make sure the sizes are correct and correspond to what you're looking at as far as, you know, where they go and those sort of things. Your vent line is on the correct nozzle if it's a 5-inch, you know, those sort of things. So that's something you can catch in a field walk in addition to some arrangement issues. So once again, we don't have to show every pipe and bend, but we do want to show that the branches are correct. Okay, so if you've got a branch off of a vent, if you've got a header line, if you've got a recirc line, especially if those lines have control devices in them, pressure relief devices in them, we want to make sure that we're accurately documenting the arrangement of the piping and our equipment. This even includes how the equipment itself is oriented. We want to make sure that we document that. If it's vertical, let's document it vertical, horizontal, same deal. Okay, so those are things that just two high-level things that in our field walks could be important. We're going to show you some examples on those. The main thing is with the field walk, know that when you're going to do it, it's going to be a tedious activity. It's going to have a lot of detail. Really, when you're doing it, a good tactic there is to also take pictures. Because the pictures will allow you to go back and look at the different angles, and because maybe when you sketch it in the field, you've got safety equipment on, it might be hot or cold depending on what season it is, or if your area is covered or not. So those pictures are really going to help you when you're going back and making your red lines to make sure you get everything correct.
Here we have a good example of how to depict a tank on a P&ID, one that has a bunch of nozzles, so it's kind of hard to get them all on the rounded top in the sketch. So we extended the top of the tank. That's what that line's depicting. Really, all these nozzles are on top of the tank. So a couple things to point out here. This really helps with spacing, really helps you to understand and see all the nozzles and see what they're doing. Another point is that we arranged these based on how we wanted the tags to go. And it's a more simplistic design. You can see the piping's not crossing each other. Because this is a P&ID and not an ISO, that's completely adequate, that's acceptable for you to do. I actually encourage it. It's going to help you follow the lines a lot easier. And then also in terms of the arrangement on the tank itself, maybe the 4-inch manway is actually on the most right side, but it kind of made the drawing more complicated to look at. That's some tools that you can use, once again, because this is not an isometric sketch. This is just the P&ID, really to make that simplified where everybody understands what's going on. As you can see here in the second one, we have a couple different sketches of basically a valve in the line. So number one, important point there, this is showing the valve on the other side of the T. So this is important to arrangement. When we talk about arrangement, this is what we mean. We are depicting what exactly is in the field because there's a branch in the piping. So that's going to be important for pressure drop calculations, for failure calculations when we're looking at our HAZOP where that valve is. What's not quite as important is in 2 and 3. Those bends in the pipe there, that's not really depicting anything having to do with the arrangement of the valve in the line and where it can go. It's still going to go in the same direction. Really, it just complicates the drawing. Maybe number 2 is a seal loop, and sometimes you want to depict those seal loops as there's an elevation drop. But even in this case, you could have pushed up that whole pipe section above the straight pipe, so that way you're not cutting in the middle of that U shape there. So what you would want to do in those scenarios for 2 and 3, you want to do something more like number 4, which is a simplified line. Once again, this is not a pipe isometric drawing or sketch. So where this really is going to come into play is this is going to be used to follow our process in our hazard review when somebody's going out to walk it down. So it's a lot easier to look at it in this simplified format.
Last thing I want to point out with P&IDs is something I see a lot at our facilities, and that is we don't keep a current up-to-date database. We look at our changes, our MOCs, but sometimes things get missed, and we never go back on a regular frequency and make sure we field walk and look at these edits, because we have some changes as well that don't require MOCs that impact our P&IDs. So the way to do that is when we have a PHA coming up, for all of those drawings for our regulatory equipment, let's go ahead and take a look at those. Let's field walk them. Let's look and make sure our documentation is meeting our P&ID standard. If we do it every time before we have a PHA, then all of our drawings, especially our regulatory ones, should get encapsulated within a 5-year cycle. This makes sure that that change doesn't incur a huge financial cost to the plant by trying to do all these at once. If we're doing third party, it doesn't incur a huge resource drain on the plant if we're doing them all at once and we're doing them with our own personnel. So that's a good way to kind of keep a steady change on these drawings. Any drawings then that you have that are not regulatory and your company doesn't cover non-regulatories in some sort of safety review, just take a certain type of time frame in that 5-year frequency and say we're going to cover our non-regulated P&IDs as well, or maybe add a couple of those P&IDs to each regulated PHA where you've got those regulatory drawings. So that's a way to keep our frequency good that minimizes our resource costs and minimizes our financial costs to the facility. Hope you like the content. As always, you can check us out on YouTube, LinkedIn, Facebook, or at our website.